Well, hello friends. Welcome back to the program. Today we are going to work on browser things, specifically the DOM inspector in the Serenity browser, because there's an issue, a long standing issue that has been annoying me forever, and it's time we do something about it. So let me show you what it is. So I've opened up the DOM here, and we're looking at the body element, which has a bunch of children like this header here, and paragraphs, and then a nav, and so on. And between these elements, we have these silly white space text nodes showing up in the inspector. And I don't care that there is white space between these elements. And I think if you open this page up with the developer tools of any other browser, then probably, yeah, they don't show that either, right? They just show the element children of body. And if you look at the source code here, we can see that body has an h1 child, and this white space here, because we parse that into a text node, and every browser will parse that into a text node, but we just show every node in the inspector, and I don't think these text nodes are interesting. They just kind of, they just muddy up the presentation here and make it harder to actually navigate the DOM, because they're noise, basically. So today we're going to get rid of these. And I'm not exactly sure how, but we're just going to start with figuring out what kind of text nodes are interesting and which ones are completely uninteresting, and then excluding those, I guess. So what makes a text node interesting? Certainly a text node that has text. So like right here, for example, or right here, if something is inside, if something has non-white space text, it's always an interesting text node. So we can only throw away white space text nodes. And we're still going to keep the text nodes, to be clear. We're just not going to show them in this inspector. So let's say that we're hiding them rather than throwing them away. So white space text nodes. But what if you have like significant white space, let's say, let's make a test page, test HTML. What if you had something like b hello, or no, like hello, b friend. In this case, in this case right here, this space here is relevant, right? Because we still want to learn that there was white space here and that the text shouldn't be like hello friend. So let's see what that looks like in Firefox. Hello. Oh, see, hello B and then white space friend. So they're kind of almost exaggerating this right here. Okay, so I think the first thing we can do is hide non-rendered white space. So white space that goes like in the head element, for example. This is not even rendered because the head element is not rendered. So we can just get rid of those. And for these things here, I guess these are gonna be anonymously wrapped text nodes. So maybe white space only text nodes with anonymous block wrappers. Okay. If you don't know what anonymous block wrappers are, let me just explain that first. So in HTML, there is this invariant, or in CSS rather, there's an invariant that a standard flow element has either only block level children or only inline level children, and no mix thereof. What happens when you have a block, something that has block level children, like this body here has a bunch of block level children, right? But it also has text sprinkled in between those, white space text. And in order to maintain the invariant that you have only either block level children or only inline level children, CSS requires that we secretly wrap these text children in what's called anonymous block boxes. So if we dump out the layout tree for this, then we should be able to see that actually. So let's go to the H1. Okay, so here's the body block container, and then it has, as its first child, is a block container, anonymous. So this one is synthetically constructed to wrap this text node right here. And then you have the H1, and then it repeats again. We have another anonymous block container wrapping this text node. And anonymous here means that this layout box does not correspond to any specific DOM node. Rather, it's a synthetically instantiated thing that just only exists to wrap some piece of inline content in a block level box so that we maintain the invariant. I hope that makes sense. So these are all going to be have a block level parent that's anonymous. So, okay, so that's what we can check for, I think. So if something is not rendered at all or has a block level anonymous parent and it's completely white space only, then let's exclude those. Okay. All right, so let's figure out, I'm not the last person who worked on the inspector, so let's figure out how it actually gets rendered. Or how the tree gets created, rather, because now I don't remember anymore. I need a handle for something to look for. Okay, so let's just look for this string here in the tab view, DOM, right? DOM. Case sensitive, and okay, here. DOM tree container in the inspector widget. Great. So you click on something, and it calls set inspected node. Sure. DOM tree view, and who is your model? Set model. DOM tree model. Okay, so we create a DOM tree model when we get some JSON. Right, this is starting to come back to me. So the web content rendering process sends us a blob of JSON describing the entire DOM tree, and then we create a DOM tree model in the browser process to visualize this JSON encoded DOM tree. So who calls set DOM JSON? Because I think we don't want to think about this stuff in the inspector, at the inspector level of abstraction, right? Let's just do this in the web content process instead, and not even bother sending stuff over to the browser. And the reason that I'm talking about these two separate processes, by the way, if you're not familiar, the Serenity OS browser is a multi-process model browser where you have a rendering process called web content, and the browser process presents the UI, but does not actually have the web content in memory. So here, the web content process sends a JSON encoded representation of the DOM over to the browser process, and that's what we display here. So let's see, set DOM JSON was called by this guy right here. Hooks on get DOM tree. Okay, on get DOM tree is fired by out of process web view from notify server did get DOM tree. Sure. Who calls that? This guy right here did get DOM tree. Wow, this is looking really messy. What's up with these build files being in my autocomplete thingy? let me just delete my i686 build and see if that helps. It does help. Nice. Okay. Did get DOM tree. Oh, that's IPC function. Okay. So somebody calls async did get DOM tree on the web content process side. Aha. Here we go. So the web content process is asked to inspect the DOM tree, and then it gets the currently active document in the top level browsing context. So that's like the currently active mainframe document in this tab. And then we send over the result of dump DOM tree as JSON. Aha. Dump DOM tree as JSON right here. Okay. That was probably an accident. Yep. I don't know what I typed there. So let's see. Dump DOM tree as JSON. So this seems like the worker function. Serialize tree as JSON. Okay, so we have a JSON object serializer. And the way we build the DOM is recursively, presumably, right? Right, so if we have children, we walk the children and serialize them into the same JSON object serializer. Okay, right. And then we call this recursively from document dump DOM tree as JSON. All right. So this is the part where we need to come up with those heuristics that would cause us to not serialize something. So what did we say? Anything that's not rendered at all, which means that it wouldn't have a layout node. If you set display none on a DOM element using CSS or the style attribute, then it will not have a corresponding layout node. So that's an easy way to check if something is rendered. If there is no layout node, then we can skip it. Or wait, hold on. If there's low layout node, we should still show it in the DOM though, because what if it's like an element that has display none? You still want to see that in the inspector. So now I'm thinking too fast. I think if it's a piece of white space text that doesn't have a layout node, then we can skip it. That makes more sense. Okay, so let's see. Let's check if it's text, because it's really just about removing text nodes. So the first part of the heuristic needs to be, is it text? And we can use that check. So if it's text, probably I need to actually include DOM text. Wait, where am I? Oh, serialized tree. Oh, shoot, I need to do that. Okay, so wait, what the heck? What is happening with the auto formatting? I'm pressing the key to do Clang format. Maybe my C-line is screwed up. I haven't configured this for a while. What the heck was the trick? Clang format. Plugins. Installed. No. Ah, dang it. What the heck was the thing? Find action, Clang format. Clang format. Oh, that's what you call it. Settings, plugins, Clang format. Dang it. Okay. I'm just going to do a restart of the IDE because something is a goof here and I'm not sure what, but it's supposed to pick up the project Clang format configuration file. But it totally doesn't. Control Alt Shift L? What the heck? What on earth? Let's Google it on Bing. Clang format CLine. Yeah. How do I configure that? File settings, tools, external tools. Okay. Tools, external tools. No external tools configured. Uh-huh. Oh, code style. Okay, editor code style. C++. Stored in project. That's the one we want, I think. Enable Clang format. Ooh, that's the thing I wanted. But why doesn't it find that? Clang format. Usually you can find everything with the search thingy. All right, well, so that's what I want to do. Oh, now it just works. Okay, well, that was a distraction, but now we're back on track. Sorry about that. Don't know what the heck happened. So probably had something to do with me nuking that x86 build folder, but the connection is not clear, but who cares? Let's move on. So we have a DOM text node, and it doesn't have a layout node. Then we will skip serializing it. Yes. Otherwise, if now we do have a layout node, let's check if the layout node parent. So we have a parent that's an anonymous block. So that will be checking if the parent is anonymous, and actually that's all we need to know, that we are wrapped by an anonymous parent. So then we can return as well, assuming that, of course, it is white space. So if it is text and static cast, text const this, data is white space. Okay, let's try that out. Probably missing something here, but let's see how this works. Okay, so here's our DOM. Crashy. Okay. Okay, so JSON decode fails now in the receiving side. So this browser process crashes because it makes assumptions about the JSON. Wait, so what's going wrong though? I guess we can just dump out the JSON we're getting and take a look at it. So what was it? Did get JSON or something like that? Did something JSON? Did get DOM tree. Oh, right. Did get DOM tree. on get DOM tree. Calls set DOM JSON. Okay, a lot of indirection here, but we're on our way. Set DOM JSON. Okay, so this guy creates the DOM tree model, and presumably that constructor or somebody was making assumptions about stuff. Who was that? It was, I can see it right here actually. Line 118. So this guy right here. Node name, get name. Okay. Wait, so we're missing the name on something. Okay, let's just dump out the JSON that we're getting. So DOM tree model, JSON, and DOM tree, let's say. Can we just dump a DOM tree like that? Nope. To string. Wonder why it matters. If you skip over some text nodes, like why does that matter? Why does that matter? Let's see. Get the empty JSON, okay. Oh, because I've moved it, right? Okay, yeah, that's stupid. Yeah, I didn't spot the move there. Usually CLion will tell you about stuff like that, like you're using a moved something. Is it telling me? It's not telling me. Okay, that's more like it. So what is wrong with this huge piece of JSON? Let's take a look. After we JQ it. Line 2. Wait, what? Can I? Oh, it's not the whole thing. Okay, let's just use the. Sometimes if you copy something huge in a terminal, and then you paste it into another terminal, then you're not actually pasting the whole thing. You're just pasting like however much that the receiving terminal could buffer. And I think a lot of times, like you don't even notice that it looks like you pasted the whole thing, but you didn't, because it only received the first chunk or whatever, first buffer size chunk. That's why I just open up a GUI text editor so I can paste there, because I know that it will actually receive the full thing. And then we should be able to JQ it. Yep. Very silly. So what would be wrong here? We have these empty objects. They look a little suspect. Not sure what those are about. And it's fine here. It's fine here, but when I open the HTML thing, it breaks. Okay, so it's something within the HTML element that is no good. Name HTML element, so something in here. All right. Oh, wait, hold on, what's going on here? So children has empty objects in it. I assume that's what's breaking it, right? So we try to serialize children, but these are empty text nodes, so we just don't do anything. But why do we open up a new object though? That was in node CPP, right? So we iterate through the children here. Oh, wait. I see. So when we're making the decision, we're making this decision too late, because by the time we get here, we've already opened a new object in the JSON output serializer thingy. So it seems like we should really evaluate this sooner. Let's see. So maybe what we should do is create a helper for this. So like bool node is uninteresting white space node. Let's put that here. So if it's not text, and what is white space? That has to actually walk the entire string. Oof, that's a bit gnarly. So let's do that last then. Let's see. So if it's a text node that has no layout node, oh shoot! But we still have to check the white space before we do any of that stuff. Dang it. Okay. Let's not be clever. If it's not all white space, just return. If you have a layout node, if you don't have a layout node, it's uninteresting. If you have a layout node and your parent is anonymous, then you're also uninteresting. Otherwise, you are interesting. Okay, that's a pretty convoluted looking function. So let's write down. This is whether a text, a node is interesting enough to show up in the DOM inspector. White space between block level elements. This removes or hides two things. White space between block level elements and non-rendered white space. Yeah, rendered white space, non-rendered white space, shite space. Rendered white space between block level elements. Yes, that's exactly what it does. Use dynamic cast, but I know that it's a text node. Jeez. Okay, yes, let's put that thing here as a helperino. Actually, let's, yeah, it can be public for now. Actually, that's fine. Okay, so if it's an uninteresting white space node, actually, let's do that when we iterate over the children. Because a white space node, text nodes can't have children, so we don't have to check it on entry. We only need to check it when we're iterating over children. So I think here, if the child is uninteresting white space, then we just skip over it. Otherwise, we serialize it. Okay. I wonder if it's going to be a problem that we're still creating, like if you have nothing but uninteresting white space children, we're still going to create the children array. Wonder if that will cause trouble. Because I feel like on the other side, let's see, children. Wait, why is there no children? Get children. Oh, okay. So we're doing a get children to get the children, and it seems to me that the absence, if you have 0 children, it should be treated as if you had no children array. I wonder if that will work everywhere. Like here is a simple, here we only do a null check. So maybe this thing here should be null check and child count check. Let's see if it's even necessary to worry about this though. Oh, dang it. Oh. Okay, here we are. Open that up, open that up. Ooh, this is looking promising. Look at these. Oh, that's so cool. See, now we only see the text nodes that we care about. No longer it's goofy text in between the elements. Just see the elements straight up. That is kick-ass. And it seems like it doesn't have a problem with these like children. If you have an empty array of children, it seems to be not an issue, I think. Super cool. Also, this comment thing here looks so silly because like we could also just show the comment. So I don't remember what the comment is, but I remember putting a comment into this test file right here. Oh, it says this is a comment. See, we could display this is a comment instead of just hash comment, right? It would also be a nice quality of life improvement for the DOM inspector. So how about we do that also? One thing at a time though. Let's see. Get children. If you have empty children though, but you would never call here. No, this is probably fine. Okay, I'm just thinking too far ahead and worrying about things that are not actually a problem. So let's just clean that up. We had some, I think that include was not necessary. And whatever this white space change here, definitely not necessary. This debug statement, not necessary. And we can still build, right? Yes. Cool. So, libweb, hide uninteresting white space text nodes from DOM inspector. We don't use a simple heuristic to exclude uninteresting white space from and declutter the DOM inspector tree. Inspector's DOM tree. Yeah. Uninteresting white space is one of two things. It is currently either these. It's currently one of these. Non-rendered white space. Rendered white space between block level elements. Yes. Non-rendered white space only text nodes. Rendered white space only text nodes. Okay. So let's see about that comment thing. So what was that comment? Hashtag comment. So I think we're only showing like the DOM tree just displays the node name, I guess, which is what we pass in the name field in the JSON. So name is, yeah, right, it's the node name. So I guess if something has a comment, we just want to pass that along. So like if is comment, then object add type comment, and then we want to, wait, how does comment store its info? It's a character data, which has a data. Okay. So then what we want to do is simply add data. Static cast DOM comment this data. There we go. Okay, now we have the data, and then we have to also present it on the GUI side. So is there something we have to do for that? I guess here's how we display text with white space collapse. So I guess if type is comment, then just get the data as string. Wait. Oh, okay, but now it looks a bit like it looks like text. So I guess we're gonna have to slap slap some prefix and suffix on that thing. So like, we'll just do this. Can do that ourselves, I think. And then let's just commit that, because that's a really nice little thing. So libweb. Doesn't take my keyboard input for some reason. Show comment contents. DOM comment contents in DOM inspector. Yeah, that's more like it. Actually, we probably didn't need the spaces there. I think that's what we want to do. Yeah. So now there's extra white space here that doesn't look correct. So, hello? Let's just amend that to the previous commit. Cool. And wouldn't it be sweet though if we also would highlight comments using the syntax highlighting comment color? So they would like look like if you look at the source code here, you see comments are gray, right? Like this, because it uses the syntax highlighting settings. And I feel like it would be a nice way to illustrate that something is a comment in the DOM inspector and not a text node by giving it the same color. So how do we do that? I think if we are queried for the model role foreground color. Oh, shoot. How do we do this? Because the syntax highlighting colors are in the palette. So there would be syntax comment right here. We want this color. Color role syntax comment. But here we're in the DOM tree model. In the DOM tree model, a model doesn't have a palette because a model is not tied to one specific widget. A widget has a palette. But a model can be viewed in multiple widgets, so it has no way to grab at a palette. I think, what would be like the big good design here? Maybe like instead of returning a foreground color, you would instead return a foreground color role. So like it would work like this, and then we would return like if type is comment, return graphics color role syntax comment, like that, right? And then otherwise just no override. I feel like that would be a good design, I think, but this, I'm not going to get into like redesigning that because there are so many clients of this API already that need to be updated to support that. So let's do the minimal workaround for now. So instead of doing that, we can just, well, this DOM tree model only has one client. It's only going to have one view because we know that. So we can also just take a pointer to it when we construct. So we can do this like GUI tree view. Yeah, I mean, this is a little cheesy, but we can do that. So GUI tree view. Yeah, like that. And then what we do here instead is just return mtreeview dot, we need to get some of those includes. And we probably need palette as well, libgraphics palette. And let's just bump the copyright. Okay, and that was the first member. So tree view, clickety clack. And then we can just ask the tree view for its palette, and it has a syntax comment thing right there. So that could work. It's a little bit gross, but oh yeah, we'd have to construct it correctly as well. It's a little bit gross to pass in the view to this, but let's add a fix me about that we don't want to know the view. It's just a temporary measure since we can't return a color role. Fix me. What we really want to allow models to return a foreground color role. Yeah. Then we won't need to have a GUI tree view member anymore. Yes. Okay, yeah, there we go. That's much cooler. Looking like a comment. Of course, when you select it, it's interchangeable, but that's really sweet. Maybe we could make these like, so this content of the style element is like all on one long line, this big style sheet here. It would be kind of cool to have multi-line support somehow. But that's a much harder problem because tree view currently is built on the assumption that every item has equal height. So supporting like arbitrary height items will require a huge redesign of the tree view class. But yes. Anyways, I'm happy with that little tweak there. So let's commit that. Yes. libweb plus browser. Show DOM comments in special comment color. syntax comment color in inspector. So yeah. This required a hack. Since we can't return a color role, since model can't return a color role directly from data, I've added a fix me about improving that. About it. Yeah, let's just say that. That's fine. The fix me is good inline documentation of that issue. Okay, so I think that's probably it for today. That's a huge improvement, actually. If you've ever been using this, it looks so much nicer now than I'm used to seeing it, just because I don't have to stare at all those silly empty text notes. Let's just double check though that it doesn't do something silly for if we have something like an empty relevant piece of text. Wait, threads HTML misc welcome HTML. So let's do one of those things where we say like we'll put something here like B and then space inside. I'm just going to double check that that actually shows up. Where is it? Here. And then B. And it has an empty piece of thing. But because its parent is not block level, right? So that's why it still works. This is an inline level element. So we don't hide that. Perfect. Okay, so I think this is going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out. I'm very, very pleased with these improvements. There's a lot more to do, of course, on the inspector tool. We've only just started to scratch the surface of helpful tooling for the browser, for the browser engine, but one step at a time, right? So yeah, thanks for hanging out. I will see you next time. Bye.